to be able to set up term projects for my students and find people in industry that are willing to host a group of students to come and observe at the Gemba what is going on. So this was a very short type of project, only a semester long, but I think this group of students came up with some interesting findings. So the students are Camille, Cécile, Yoon, and Ruth, and our industry sponsors from Webcore Concrete are Aishan Jayaman and Patrick Schuler. So I still am not quite sure whether Aishan or Patrick or my students came up with the word receding edge, but here is what we're going to be talking about. Okay. It's all about scheduling, and it's all about how we define activities, and I was very interested this morning in hearing this discussion around tracking work and defining work and structuring the work, right? Because ultimately that's what we're interested in. The challenge with many people's conceptualization of activities is that we think of them as very discrete chunks of work, and then we can put them in our schedules and we can calculate start dates and end dates. And it is as if then, of course, an activity will start exactly at the time that our schedule says and finish exactly at the time that our schedule says. And of course, nothing could be farther from the truth, right? Things don't quite start exactly at the very moment. Usually, when we have consecutive work, we're not too sure when the predecessor starts. If our contract says we have to show up by a certain date, well, we will show up, but maybe we just send a scout out to come and see if there's actually work to be done. And then if there's work to be done, then we'll get more people to actually come do the work. We can catch up. And then if we've been smart, we will have said in our schedule, we will have agreed to a duration that is actually somewhat padded, as in we know we can get done, but we give ourselves a few extra days so we can actually commit to the 10 days, right? So there is some fuzziness both at the start and at the end. And the other related question is, if we define activities, how should we group them, right? Should these be two activities? What's the relationship between the activities now that we've acknowledged that there may be these fuzzy edges? And should they perhaps be treated as one activity? And the whole discussion that we've been having about tactile planning is exactly around that, right? It's what are the smaller chunks, and how can we group these larger chunks in train wagons, for example, and then how can we move these train wagons through the system? Fuzzy edges are a problem. They're a problem for the contractor who's managing the work. It's also a problem, of course, for the successor trades, because if you cannot be reliable, the next trade has a hard time planning to do their work. We sort of go by this presumed ideal, and this is really still a research question. I said this was a one-semester project. Our presumed ideal is that, if we can keep the front activity kind of together with that back activity and have them both be performed repetitively through the project, we will be better off. And ideally, we would have a predictable cycle time and consistency of performance. Okay, what are there was one before. Okay, so the current conditions are that when work starts, people are very interested in starting the work. And we know, of course, that the activity needs to be finished, but oftentimes there is less attention paid to exactly how we finish the work. And as the start may be starting for repetitive activities at set time intervals, what we've observed is that the end of these activities as they start kind of stretch out. So the beginning, the end is close to the start, and then the next iteration gets a little further out, next iteration gets a little further out, further out, further out. And at the end, the contractor may find that they have a lot of cleanup stuff and wrapping up to do before they actually can call the job done. And we're all familiar with the problems, right? We see activities are started despite the fact that they're unsound, or as Roland says, with the lack of a complete kit. And the unfinished work in turn then results in this making do mentality, or what Carlos Formosa and others are calling the informal work packages that kind of appear on the job because it's obvious that work needs to be done. It's just that it wasn't quite planned as well as it could have been earlier on. Okay, so what is the receding edge? We're still a little fuzzy on the definition, but I think with the examples it'll become clear. So it is work that appears to not have been completed for the contractor to actually move on to the next iteration of that repetitive work. But nevertheless, that must be completed for the contractor to be able to call their work not done, but as we say, done, right? Done and out of there. You don't have to come back. Okay, the challenge is the receding edge sounds like it may be a small piece of work. We have some data from Webcore Concrete of all the hours that they spend on cast-in-place concrete work. What they call receding edge work was about 15% of these hours. And of the 15%, about 10% had to do with, patching and fixing and those kind of things, right? So I think that gives us a sense of importance of the receding edge work and that perhaps we should pay more attention to it for, again, the contractor as well as for the succeeding trades. Okay, assumptions are, we find that activities actually are ill-defined in terms of not just the front end, the leading edge, but especially the receding edge, their completion times. And that the steps to be performed for the activities are not necessarily well articulated, and that in fact, we have very poor what we call process capability, and I'll come back to that in a minute. The hypothesis is that by defining and standardizing receding edge work, we can actually have improved performance. Again, for this project, we didn't have a chance to measure that specifically, but that's where we're going. Okay, process capability. What is process capability? It is a term, sorry. Can we go back one, please? Is a term that's very common in manufacturing, but it's not widely used in construction. In construction, we talk about means and methods, and we assume that the contractor has means and methods, and they'll know how to do their work. But of course, there are many ways to do the work. If I ask you to build a floor, do you want to have a super flat floor or just a flat floor? It's really a matter of functionality that's desired that will decide on what means and methods the contractor is going to choose. And what's important about process capability is that we must be able to predictably produce an outcome, right? Predictably, still characterized by some kind of probability distribution, will never be 100% perfect. But at least we want to have some sense of consistency and ability to achieve a certain output, and that's process capability. Okay, so with all that sort of theory, let me move on to talking a little bit about the project. So the project that we looked at is a high-rise building in San Francisco, 55 stories, south of Market Street. It actually was erected in a 3-day takt time, floor by floor by floor. So Webcore Concrete is very good at enforcing that takt time, and every 3 days, move to the next floor, move to the next floor, move to the next floor. But the receding edge activities in this case were a challenge. So students and I went out for a Gemba walk, and we also reviewed the literature on what we could find about not just starting activities, but ending activities. Can we do the next slide, please? Okay, this is what the receding edge looks like on this project. So 3-day takt time, it means on day 1, you have a lot of people out there putting in rebar, putting in formwork, putting in safety caps, putting in everything they could put in. Actually, on a second shift, the same day, they start placing concrete, right? And then once that is finished, then they can start preparing the next floor after that, right? And they have 2 days to move on to the next floor and so on. So that's the leading edge. What does the receding edge look like? This is the receding edge, right? So this is the floor below after the forms have been stripped. Obviously, a lot of shoring material, formwork material that is going to have to be flown up 2 stories up. But you also see components such as this one, right? What is this? This is a strap, a safety strap that the iron workers were using when they actually were doing their erection work. It gets cast into the concrete, but it needs to be removed before the concrete contractor is done, right? So that's what we're talking about. So this is what the receding edge looks like. So we went out and actually looked at the kind of work that needs to be done. So floor need patching work, ceiling had some dripping concrete, right, which does not meet the quality specifications. So they had to get out and fix that. One of the challenges that this contractor has is in fact that they have 2 different trades performing the work. So they have carpenters doing all the formwork up front, and then they try to use laborers for the receding edge work, although there was some work still to be done by the carpenters in the receding edge work as well. The reason is that the pay rates for laborers are different. About 70 or 80% of the pay for carpenters, and so the contractor is trying to save money in having two skills. The problem is that by having two skills, one skill essentially on the leading edge, another one on the receding edge, is that there is little feedback, right? So if we see all these patches, maybe there's something that the laborers could tell the carpenters to do to avoid the patches. But that is a difficult conversation. Okay, so consequently, we observe all the patches, we observe the repair work that needs to be done, and of course there are countermeasures, proactive countermeasures, what can we do to prevent? Reactive countermeasures, which were the ones that we actually observed in the field, right? So, and even in the reactive countermeasures, there didn't seem to be any process at all, and so there's an opportunity to standardize, to be more systematic in terms of cleaning up. But of course, ideally, if the concrete is dripping, maybe proactively you can try to avoid the gaps from occurring. So you can put on tape on the formwork, or you can put on a filler material so that there won't be any dripping, right? But again, it's feedback that needs to come from the receding edge to the leading edge to do some more work. And of course, they're already working in a frenzy to maintain that 3-day tact. That's the challenge. Another example is that a lot of leftovers materials are going to remain on the site. As you can see, hopefully here. Okay, as you can see here, a lot of leftover materials that are around, and the question is, why are they there, and is there something we can do to avoid them? Again, proactive countermeasure is maybe we can count things better, so we don't have excess materials. That doesn't apply across the board, but it may be an opportunity for at least some of the material that's left behind. The reactive countermeasure is that this contractor says, oh no, we have a clean-as-you-go process in place. We do that clean as you go. But of course, once you're out in the Gemba, it was not observed. What can I say? One of the options is, in the proactive end, is to actually use carts and is to actually use carts. I took the liberty to take a picture from Veideke's manual proactive waste baskets, right? Get people to have an easy ability to clean up after themselves. That was an easy to adopt suggestion. In fact, this is a picture on another project, but from Webcore Concrete, that I took because I thought that was a good idea and they implemented it right away. Okay, so these are but some examples. Next slide. What are the findings of this work? Well, one is work processes are defective or they're non-existing at the receding edge. We think it's really important to spell out process capability to figure out who's going to do what, where, when, and how. Interestingly, as I was doing the literature review with the students, we read a lot about Laurie Koskela's 8th waste, which is called making do, which is obviously what we observed on this project. I don't think what we observed is actually an 8th waste. I think it's a defect, one of Ono's waste, and it's a defect in the design of the method that we provide as input to the crews to do their work. Right, so we'd like to work on process capability and improve process capability so these defects can go away. We can define standard processes. We must designate resources also to do the work and not just say, oh, just go clean up this stuff without having an idea how much work is involved. And ultimately, we think this will have quite a bit of impact, not just on the contractor themselves in being more predictable in getting out of there, but also on the contractors that follow them that otherwise have to work in a very cluttered workspace. Okay. Next slide, please. Okay, so contributions. We articulated this receding edge. It's still a little fuzzy, but I think you get the idea what we're talking about. It's about finishing the work so it's done. I think the main takeaway here is to think about process capability as one of the defects that we are dealing with in our construction sites, and think about how we may be able to improve our process capability so that this defect can go away. Thank you.